Stan Gibilisco here. I have a very simple lesson from my book, Electricity Demystified, second edition. I will provide a link to the Amazon page for that book in the description of this video. Meanwhile, here is what the page looks like. You get to look inside. You can decide, sort of from the content here, whether you'd like to purchase the book or not, new or used. You get an idea of my writing style and my illustration style, things like that. However, the purpose of this video is not simply to promote this book, but to promote, in addition to this galaxy with a black hole at the center, just like the black holes of Dakota Territory, United States of Advancement of Knowledge, where I happen to live, a principle involving currents in parallel. Suppose that you have a battery and a circuit with a bunch of loads connected in parallel. Usually these loads would be resistors or light bulbs or other things. This is a direct current circuit, a DC circuit. Suppose that this particular component draws a current called I sub 1. This component draws a current called I sub 2, I sub 3, and they can be anywhere from 2 to hundreds of these components in parallel. Each one has a certain DC resistance determined according to Ohm's law. R equals E divided by I, so the voltage divided by the current, that's the resistance of the component. So if the current is 5 amps and the voltage is 10 volts, then R equals E over I equals 10 over 5 equals 2 amps. But the point is here, when you have a bunch of current drainers like this all connect, drainers, have you ever heard that expression used? When you have a bunch of loads connected in parallel in a DC circuit, they each draw a certain amount of current. Then the total current demanded from the source, in this case a battery, is the sum of all of these currents in parallel. So, say if there are 4 of them, you have 1 amp, 2 amps, 3 amps, and 4 amps. That would be a total of 10 amps being drawn from the source. It's that simple. Current demands in parallel add up in a simple, straightforward way, just as resistances in series do, or as capacitances in parallel do, but those involve alternating current circuits. This is a very simple direct current circuit principle. When you connect a bunch of loads in parallel, you increase the amount of current that is required of the source, in this case a battery, and the total current demanded from the battery is equal to the sum of all of these. So I equals I sub 1 plus I sub 2 plus I sub 3 plus ... plus I sub n, where n is the number of loads connected in parallel. That's really pretty simple. Simpler than life is in most aspects, but a lot less complicated than what's inside of this galaxy, far, far away in an unknown universe, in an unknown set of universes, in an unknown thought kingdom. You name the kingdom. You name the set of galaxies. You name the galaxy. I'm too absent-minded to figure it out anymore, or even offer a suggestion. Once again, there's a link to this page, Electricity Demystified, second edition, available at Amazon.com. Just click on it, go. Please buy the book. Don't let me starve to death. Stan Gibilisco signing off for now. Until next time, so long.